Hello, everyone. I'm Marc Sokol, Executive Chairman at VirtualZ, and thank you for tuning in to our seminar. And I just want to tell a little bit of a story before we start. One of our customers, a large Fortune 500 retailer, took a VSAM file, 60-odd million record VSAM file, and we moved it to Postgres, running in the cloud. No staging database in the middle, no CDC, no code. And the transformation and the movement of that data sustained over 56,000 records a second. So instead of just putting that on a slide and sort of calling it a day, we figured we'd actually walk you through how it works and what it means, because the number itself isn't really the point. The point is what becomes possible when getting data off the mainframe stops being a 6-month project. And my colleague, Vince Ray, who is the CTO of VirtualZ Computing and was the original author of Top Secret, drove the vision behind what's become Broadcom's mainframe portfolio and has really been a leader in mainframe and Linux computing going forward. So let's go to the next slide. And let's talk about the problem. And I just want to focus in on the right side of the slide. Even today, here we are in 2026, 70% of the world's transactional data still originates on the mainframe. And that's all the data that AI and analytics and all the modern applications need in order to operate in these large corporations. So why is that a bigger problem now than it ever was? And you have sort of 3 approaches. Maybe Vince, you can talk us through those 3 approaches.
Yeah, well, and just to build on your example, I think the customer you're referencing had actually been through all of these 3, so it certainly hit home to them. I mean, something we see a lot of folks do is they'll go down the path of ETL, extract, transform, and load, and the idea there is that you have to know the structure of your data, and you do something. You use a utility from one of our competitors. Maybe you write custom COBOL programs. Whatever you want to do, you create data dependent scripts that can transform your data into something useful. And of course, the problem with that is that it's very brittle. Every time your data changes, your scripts have to change. It can be very slow because you're going to pass through that data many times. Once to transform it, once to transmit it someplace, and so on and so on. So and of course, the biggest issue is it's a lot of work. If you have the site that we're talking about one example file, but as part of an application migration they had going on, there were literally tens of thousands of files. So, imagine the amount of work. If it took you a couple of weeks per file to figure out the structure, do some ETL coding, I mean, it just doesn't scale that way. So, that's one path. But again, it's very common out there. We see it all the time. Number 2 is, and maybe it's because some of the other solutions are so slow, we tend to see a lot of people trying to, not just do one-time things, but, move that data where it's going to go and then use change data capture to keep it synchronized. And, honestly, the issue here is that because it's so slow to get your data where you want it, once it's there, you don't want to do that again. You want to just send deltas. You just want to send the changes across as they occur, so that you don't have to absorb that pain over and over again. But again, the devil's in the details here. To do that, you have to, we're talking about VSAM here. You have to turn on VSAM logging. You have to manage all of those logs. There's performance penalties for doing all of that. Additional storage required. I mean, there's a lot of operational details there. One other customer we had spoken to a while back told us they had spent 2 years, and that's not an exaggeration, it's directly from the customer, 2 years trying to get a CDC approach working, and they never could get it to the point where it worked. And these guys, honestly, they were one of the better that I come across. They knew what they were doing. They were very talented. They were large organization. And in frustration, they basically gave up and went back to the drawing board. And then, and I think we're touching on it, but the bottom point you see there is that there's always an operational side of what we talk about. You might have constraints for whatever reason. You might have batch windows to worry about. You might have some of the other solutions that are out there use the concept of staging. Get your data from the mainframe to some other tier, and then from that tier out to the target. And that staged approach creates all kinds of complexity. What do you do if some piece of that breaks? A network pipe, or a disk fills up someplace, or these tend to be really hard problems to deal with at large scale. And again, if you're in that position where you're not just doing one or two files, you're doing tens of thousands of files, the operational side of that gets to be very, very human cost intensive, and it's something that we can help with a lot too. All of the things that Marc touched on really help this. I mean, the truth is, all of that transactional data is on the mainframe, but the reality is everybody wants it on every other platform too. So this is a problem that almost all mainframe sites face. And until we came along, I'm not sure there's been a great answer here.
Thanks, Vince. Hey,
Yeah,
Jeannie, why don't you switch to yeah. So let's just talk a little bit about that 56,000 record per second. Um, Maybe Vince, just so we can show um, the viewers that this is not sort of a setup lab. Why don't you talk a little bit about what the actual setup was and how we accomplished this?
yeah, and of course, and I'm sure everybody watching understands that. I mean, there's no magic in the universe. A lot will depend on where you're going, what target you're choosing, how much bandwidth you have, how much capacity you have on your mainframe. I mean, there are many variables here, but what this customer did, number one, they're starting with what I would think of as a medium-sized mainframe environment. Wasn't the latest, greatest, biggest possible configuration there. They had, I would think of it as a pretty standard VSAM file. I mean, it's not just the records, it's also those records were very large. They were anywhere from 4K and up record sizes. So, lots of data. And, what was unique is that this site also had a mix of VSAM, different types of VSAM, QSAM, sequential files, and they were able to use the same tool for all of that data, not just for the VSAM records. But in this particular case that we're talking about, the target that they chose was hosted Postgres running in the Google Cloud. So GCP-hosted Postgres. There was nothing particularly unusual about the target. It was, pretty standard cloud configuration. It's not like they had, 1,000-way shared cluster or anything like that. It's a, very straightforward, standard Postgres environment. They used, their existing infrastructure, so it's not like they went out and bought more bandwidth or anything like that. I think, and that we could go into a lot of detail about this part, but in reality, they had nothing more than 10 gig connections between their data center and Google. And the important point is that 10 gig is shared across not just our data, but everything else they're doing. And they have plenty of other applications that are also running across that pipe. So, when we tried to put some numbers to it, it didn't seem like we were using more than 3 to 5% of their network bandwidth that way. So on the mainframe side of it, one of the advantages we bring to the table is our product runs as a zIIP eligible workload. So, they happen to have zIIP processors all set up. We used their really their existing environment that way. We just slid right into it and we're able to run that way. To put it in perspective, I'm going to call it the incumbent solution, was based on one of our competitors' products that does some of the things I talked about before. It stages the data to a gateway and then writes the data from the gateway to the target. Not necessarily optimized for a lot of modern mainframe technologies. And what they were accustomed to on this exact file, and that's why it stood out so much to them, is instead of the 2-hour number here, they were accustomed to this running for 2 days. So, their standard test was, I submit it Friday night when I go home from work, and I expect to see the results Monday morning when I come in. So, to go from that to the whole thing ran in literally just a couple of minutes was, really just shattering to them. They had never experienced that. And frankly, I think there was a certain amount of disbelief. But, when we step through the architecture we use, how we do things, the fact that we don't, when I think of those staging solutions, that's once to read the data off of VSAM, once to write it to the staging environment. Staging environment has to read it again and write it to the target. I mean, that's at least 4 passes through this data. We do it in 1 pass through the data. So, it made perfect sense that, we were dramatically faster. And, really the most important part, separate from all of these performance gains and the fact that we're able to do everything we do running on that zIIP engine, so there was no cost impact to their mainframe software bill of running us there. They actually did this with 0 lines of custom code. It was just, run our utility, command line functions, choose the right options, and they were running in minutes once they were set up to go. And it wasn't an outlier. I mean, we did all of the kinds of data they talked about. We did, in this example, VSAM data, we did sequential files, we did archived tape data. And in fact, one of the cool things we did was, we have a technology we refer to as the multiplexer, where instead of doing these things serially, one after the next, in a long stream like that, what we do is we can give you a way of saying, here's a list of 1 million files or however many files. Do them 100 at a time or 1,000 at a time or whatever you have the resources to support, and we handle the rest from there. So, we were able to use that capability with the customer that we're talking about here. And what had been this kind of cumbersome, long sequential process suddenly became, just hit that enter button. We manage the rest. It's clear what worked. It's clear what didn't work if there was some kind of error along the way. And, all of that pain just went away. So yes, definitely, definitely a lot of color. And by the way, anyone who might be on the call, if you have questions about any of those details, I'm pretty familiar with the environment they ran under.
Thanks, Gene. You could switch it. It's funny, Vince. I can't tell you how many times I've been in a situation where the new solution that I was promoting ran so fast that the customer assumed that there was a problem. And you suddenly are in this situation where they call you up and they say your product failed. And you ask them if they've looked at the output file yet, and they hadn't because they assumed because it ran for 30 seconds or a minute or 5 minutes that it failed after the prior solution was taking an hour or a day or a year. And then they look at the output file and they say, "Oh no, the output file looks right. I guess it did run." It's the situation exactly like that.
Yep. Yeah, and yeah, exactly right. I mean, we hear that all the time. It ran a couple of minutes. I thought it must have broken, and then I figured out the data I wanted was there.
Yeah, exactly. So we'll talk a little bit about how PropelZ works. We know it reads at the source. We know that it can transform from the various mainframe data formats, and it's able to deliver to any target. In the case of this customer, we were reading VSAM, doing transformations in flight, and focusing on Postgres in the cloud. But talk a little bit through about how it works and what are the options in these three silos.
Yeah, and that's a really important point. I mean, our PropelZ product, as you see on the slide, it's really these three stages. It's kind of an input phase, processing phase, and then output phase. On the input side, we can basically read anything you want to. It could be, it could be files. It could be VSAM files. It could be sequential files. It could be tape files, GDGs. It could be, anything you're likely to find on a mainframe. And in fact, it doesn't even have to be mainframe data. With the current version of PropelZ, we can do things like connect to a non-mainframe server over NFS or Microsoft's SMB protocol. So we can connect to a share on a Windows server, for instance, and ingest a file that we find there. So really anything is possible as input. Now, when we talk mainframe files as input, one of the challenges everybody has is that those files tend to be really complicated. They're not just text generally, they're combination of text fields, binary fields, floating point fields, packed decimal fields, you name it. And those structures can be just enormously complicated. So often it's not really a lot of value just to take the input unchanged and store it someplace. I mean, if you need that, we can absolutely do that. But most customers need to transform that data. So, you can give us a little bit of metadata, which is generally something that looks like a COBOL copybook that you would already have that describes the records. And we can use that to understand that data, not at a record level, but at a field level. So field by field, we're able to understand and interpret that data. And then that allows us to store that data in whatever target you want to go to. So, let's say you're going, like the example I used before, you're going to a Postgres environment. You might need to transform that blob of a VSAM record into many discrete columns, and those columns have to be stored in whatever the database expects, not mainframe style, this, that, or the other thing. So that's exactly what we do in PropelZ. We use the metadata that you supply, and again, zero code. This is totally declarative. Just here's what my record looks like. You give us that, and we handle the rest. And so the output of that is very similar to the input stage. The output stage can be almost anything. The most common thing we see is that it's a database of some sort. We can connect to any JDBC target, so any relational database, any NoSQL database, as long as it's got a JDBC capability, we're able to connect to it. And the important thing there is that allows us to do very significant optimization. We do bulk operations, we do large batches, we defer commits and transaction processing, and that's what gives us the performance that we see. Many of our competitors do web services, for instance, and when you drill into it, they're using HTTP transactions, and that means every record tends to be a transaction, and that means a connect and encrypt and SSL handshake, all of that stuff. We don't have any of that. We have one single JDBC connection and then a stream of data that's as efficient as it possibly can be, and that's how we get the kinds of performance numbers that we do. That optimization that we can do on the output stage lets us do really the best that's theoretically possible given what the target. So it's as you see on the slide here, it's any input, any output. So I can do mainframe files to a database. I can do mainframe files to, for instance, cloud storage. I might have an S3 bucket, or a Google object storage file, or Microsoft Azure, or whatever it is. Absolutely, we can support that too. The transformation I described doesn't have to be rows and columns in a database. It can be things like VSAM to, let's say, a JSON format, or an XML format, or a CSV format, or really the sky's the limit there. And by the way, one of the other things I'll just mention quickly is that the output we do can also be API driven. So, sometimes you want to do something custom with that data. We have an example where we want to talk to Splunk. We take some management data from ZOS and we want to write it into the Splunk product. Well, that's not JDBC. That's not, object storage in somebody's file system. That's a case of proprietary Splunk API. So it's very easy for us to do. And then, just to kind of, close the discussion here, everything I'm describing is open in our architecture. So, if you need something on the input side or the output side that we don't support, I mean, certainly we would encourage you to come talk to us about it. Maybe it's something we can do for you, but you're more than welcome to do your own. You can plug right into what we do in exactly the same way that we do. You get all of those same benefits, and it means that you don't have to be dependent on us to control what the inputs and outputs are. You can do that. If you don't like what we do, or if you need something that's just so specific, yours is the only one on the planet, and you have the only expertise at that, you're more than welcome to do that. Right, Marc, I think you're muted.
Thank you. That's really a powerful part of the platform, because in many cases we're dealing, especially through systems integrators, with purely custom software. maybe a specific banking solution or manufacturing solution that was developed 20 years ago, and it has some proprietary data formats. And this our product would allow you to be able to have that data format both as input and output if you needed to. And it's really unique because it's an open platform for both the input side and the output side. Yeah, it really is the product itself has grown from our first conception of it to where it is today. I'm not sure this. Sorry, I got a little mixed up onto what slide we're on. I mean, effectively, this product allows us to sort of provide this sort of custom replication across the mainframe and through the Linux world. Is there anything on this slide, Vince, that you'd like to highlight?
Well, I'll just give the example. I mean, we often talk about PropelZ as, PropelZ runs on z/OS and the inputs and outputs could be anywhere. But we actually had a customer that came to us that had data that originated on a z/OS system, but they wanted to process it from Linux. And so, these days we do have that ability that PropelZ itself can actually run just about anywhere you might have a Java environment. So if you want to run it on, let's say a mainframe Linux or an Intel platform Linux or Linux hosted in the cloud someplace, perfectly fine. And all of the same inputs and outputs, same structure I talked about, all of those same features are possible. So if you're in that kind of business model where, maybe your customers are sending you data that's in a mainframe format or in, God knows what format, and you want all of the things that I'm talking about, mainframe doesn't have to be a part of the execution environment. You can run PropelZ anywhere that you want. And, we have all of those same features. We understand EBCDIC, we understand all the mainframe data formats, and, you can process that from anywhere.
Right, next slide. So let's talk a little bit through these use cases. Whenever you have a sort of a horizontal platform product like PropelZ is, you immediately want to make it clear that there's tons of use cases for this product. I want to talk through a couple of these, Vince.
Yeah, I mean, certainly, I would say that one of the most common things we hear about is that application modernization piece. It's, for whatever reason, you decided to rehost an application or extend it by putting a part on another platform. And with that, you need to figure out how to get to the data or move the data or get the data into a format that your applications can work with. That's like the standard story that we hear all the time. Sometimes we also see things like it's not necessarily application centric, it's things like report migration. I can figure out what to do with the application because it's my code, but I might be using something like, I don't know, SAS or EasyTreeve or, whatever reporting tools. And it's not so much the software that I'm worried about, it's the reports themselves. So, that sometimes comes up. We see a lot of, even within the mainframe, we see things like VSAM to DB2 conversion, where, we have customers that are looking to take that VSAM data into a database format. And, to us, DB2 is just another database. So if we can do it to Postgres or Oracle, we can certainly do it into DB2. And then, of course, the benefit is it's automatically transformed and structured into neat rows and columns the way I just described. So, that's one category, and, certainly that's the big one. We also see things like, you see integration platforms. A lot of customers will have, web methods or MuleSoft or, Microsoft Stack or, the many of these out there. And, a lot of times the hole in the structure is, how do I get mainframe data either in or out? And PropelZ certainly can fill that need as well. Analytics and reporting. I mean, this is really a different approach to report migration. Sometimes you're just looking to move the data around, but sometimes you want to use different tools. One of the demos you'll see on our website is we show taking a VSAM file of information, putting it into, I think we use MySQL as the target, and then the advantage of doing that is we turn around and use Tableau to do analytics and reporting on that data. So we go from kind of old legacy mainframe-ish stuff to kind of modern technology in literally just a couple of minutes. So, there are a lot of cases, and, certainly today, more cases around AI where that's the desire. It's not so much I'm rehosting anything, it's that I want to leverage that data in, something like Snowflake or Databricks or, some other tools where it would normally be, difficult to do that. So, many of the things that we do are designed to plug right into that. We hear that pattern more and more these days where, hey, I'm not looking to necessarily do any kind of my app migration. What I'm looking to do is, get my mainframe data into an AI environment in kind of a low friction way. So that's definitely a focus, and I suspect that'll be an even more important focus as we go. And again, the challenge there is, it's really all the same things that we've talked about. How do I go from this complicated unstructured data that is very mainframe dependent into something that is easy to work with no matter what tools I want, and that fits the AI approach just as much as really any other use case. And then finally, storage and security comes up quite a bit. I mean, the way I look at it is, I'm sure everybody watching has ways of dealing with cloud storage as an extension to their current, Windows platforms or Linux platforms or whatever else you have. If I'm running a big Windows server app and I need more storage, in 2 minutes I can do that with, S3 or Azure or Google or really whatever I want. The problem is the mainframe's never played in that. Mainframe has just kind of looked at that, and we've just never had that. So we bring that to the table here. We have through our FlowZ and Zaac products, we're able to really close that loop, and certainly depending on the use case, PropelZ fits that too. If you tell me I want to take I don't know, my log files or my SMF accounting records or whatever it is, and I want to archive to the cloud instead of to maybe tapes or whatever I'm doing on my mainframe, I can absolutely do that. We can give you a solution for that sort of thing that takes away that need for lots of storage there. So often this will be more than one of our products, depending on what problem you're trying to solve. But it's just different faces of PropelZ and how we're able to use our technology to solve really wide range of problems. And I guess I'll put my business hat on for a second. The intriguing thing is that your license lets you do all of this. It's it opens the door to, oh, I have a problem in any of these spaces, PropelZ the answer. because it has good capabilities no matter how you want to use it. So anyway, I'll stop there. Turn back to you, Marc.
Great. So, I think it's very important to position PropelZ not just by itself with the kind of functionality that Vince and I have talked about over the last few minutes, but also to compare it to what exists prior to PropelZ. Because I think, and Vince mentioned this earlier, the complexities and the problems and the time it took to do these data movement tasks were so difficult to manage that many times our prospects and customers simply gave up and ended up trying to solve the problem in another way, maybe changing their business or changing their expectations of timeliness of data, which had a business impact. And so I think, Vince, you need to talk a little bit here about why it's different doing things with PropelZ versus, in this case, with traditional ETL and change data capture.
Yeah, and maybe it would help if I just shared a couple of examples of things that we've heard from customers. So the site I mentioned that it spent 2 years trying to deploy a CDC approach. One of the examples they gave us was that when you turn on VSAM logging, RLS and logging and all the options that go with that. The way this model works is that every time you update a record, there's going to be a copy of that record in that log. So number one issue they ran into is that meant that all of the I/O they were trying to do took at least twice as long, because now it had to be written to a journal as well as to the underlying VSAM file. So right away they ran into a whole slew of performance issues like that. But the bigger problem for them was that when you're working in this mode, those log records have to persist until the transaction ends. So let's say you have a really big batch job that's going to open a VSAM file and update every record, write a new version of something into each of those records. When you turn logging on, what that means is that your journals are going to have to be as big as the VSAM file that you're dealing with. Essentially you're going to write the VSAM record, you're going to write a log record, and probably more important than that, while you're doing this, no other work can reference those records. So all of a sudden you have potential for deadlocks and delays and interactions with online transactions that are being impacted by your batch work. And the answer is, well, open up the logic of your batch program and insert commits every 100 updates or 1,000 updates, or whatever makes sense to you. But of course, nobody wants to do that. I mean, that's you might have 1,000 programs to change in order to make it run more smoothly. So these are the nature of the problems they run into. What happens when I have a simple VSAM file, it's a couple of gigabytes, but the log files get to be a couple of gigabytes, and all of a sudden applications start being delayed because of all of this. And how do we recover from all the outages that can, this is, multiply that by the number of applications you might have in a big site, and that's where the problems came up. So again, our approach is a little different than that. Our approach is an asynchronous one. We have the ability to look at a file system object and say, what's changed since the last time we looked at this file, and we'll just transmit the changed records instead of the whole file again. So, we do it in a fundamentally different way, but the beauty of what we do is it doesn't need any of that, operationally intensive stuff. There's no logs. I mean, if you have some other reason to do it, great. We don't care either way, but we don't require them. And in fact, we can do what we do outside of VSAM. Everything I just described is VSAM only. So if I've got, I don't know, sequential files on disk or tape or whatever else it is, none of those techniques work. So what we do works for sequential files, works for VSAM, doesn't require logging. And really the only trade-off is that it's asynchronous. There could be, and actually you get to tell us, here's how much of a time lag I can accept between a record being updated and when it's updated on the target. If you have a really critical requirements, that could be a couple of seconds. A lot of sites though tell us, I'm good once an hour or even once a day. I do big updates in a batch process and I really just need to do the incremental synchronization after that's done. So instead of like constant overhead trying to keep things in sync, we do it in a much more controlled way, much less overhead, much less much less challenging to recover from errors, so on and so forth. In our case, if something goes askew, the very, very worst case is just synchronize it again. Just take a snapshot of the entire file again. And as we talked in the beginning, at the performance we get, that's not a particularly painful thing to do. So it is just much more orderly way of doing things that's much more tolerant of operational issues, and the kind of thing that you can actually be up and running in real world use cases very, very, very quickly. The other thing too that kind of comes into play here is that something we hear loud and clear is sometimes with our competitors' products is it's difficult to tell when something goes wrong. Where do you look? What do you do first? How do you even know that you've got a problem? In our case, because we're weeding out a lot of those intermediate steps, it's very clear. We run, let's say we have PropelZ installed on ZOS and we're reading a VSAM file and writing to Postgres. If something isn't right, immediately. And in fact, that can be integrated with whatever automation products you have. You want to send an alert to OpsMVS or whatever your favorite automation tool is, we can do that. And there's no magic there. This didn't work and I better go fix whatever. Maybe I had a network glitch or ran out of space on the target or whatever it is. The exact error message we see from the target database is displayed, so there's no guesswork there. And that's a really important piece of it here. And again, I go back to that customer example I gave, where you might have tens of thousands of data sets moving back and forth constantly. If you got to not just have that infrastructure, but have some kind of infrastructure that lets you manage that and detect problems and, did it really get there? And, test all of that. That gets to be a Herculean effort to deploy that in a large production environment. So, our approach, keep it simple, keep it fast, keep it, as lightweight as it possibly can be, keep it as secure as you want it to be. We support whatever your target supports in terms of encryption and security and credentials, all of that. I mean, it's, and we've seen it, and kind of to use Marc's example, we've had cases where will go to customers and say, you could be productive with this almost immediately. And, they're accustomed to these, 6-week heavy lifting tasks, and they just can't get that. It takes a while for it to sink in. But that is what we're all about. It's take the software. It's trivial to install the software, but once you get past that, it's just figure out the command line options you need, and you're running. And that's that. And it doesn't really matter too much whether you have one simple target or hundreds of targets or hundreds of inputs, or all those little details are very easy to accommodate for us.
So I think we covered sort of what PropelZ does and how it does it, and how it does it in a much more simple, straightforward way than the alternatives. It's funny. I remember way back when we first started this business, we were talking with a large systems integrator, and they were showing us the diagram that they created that described the process they went through to get mainframe data into this cloud environment. And just the number of components from various vendors and the connections between those components, all of which was a pretty straightforward solution, pointed to the fact that not only is it difficult to set up and expensive to set up, but the likelihood of one of those small pieces failing somewhere along the line is very, very high. So anyway, just to be assured that you can get the data to where you want it in a reliable way in a short amount of time is enough of a reason in itself. For PropelZ, I thought I'd talk a little bit here and put Vince on about how we license the product. We come from a background that's very used to the various ways that software vendors license mainframe software, and I thought we would talk a little bit about how we license it as far as its components, how it's deployed, and sort of the predictable, cost-effective way that we license. Vince?
Yeah, so normally the model that we use starts out with, there's a core PropelZ product. It's licensed on I think of it on as a per platform basis. So clearly not a per LPAR basis, not a per system basis, per platform. So your ZOS license lets you run as many copies as you want. You could have 100 LPARs if you want. They can all run PropelZ under our license. If you were to install both the Linux version and the ZOS version, that would be 2 licenses. So that's the core piece. And then in most cases, we have kind of a pick and choose model for the connectors that you want. And again, everybody's a little bit different in terms of what you want to connect to. Last thing we want to do is see you paying for 100 different connectors that you have no use for. So you tell us what you need that way, and if you need, let's say Oracle, we make that happen. If you need, really whatever combination you want are done that way. Typically, the connectors follow the PropelZ license. So if you have PropelZ license for ZOS and you need, let's say Oracle and something else, you might have a core product and you'd have, a couple of connectors added on to that. And we call them connectors, but there are also some optional facilities in there. Things like, I mentioned our multiplexer that lets you scale PropelZ to extreme levels. We treat that like a connector too. It's an add-on function to PropelZ. That's totally optional. You can do it. And by the way, I want to stress what I said before holds true as well. If you wanted to take the core PropelZ and develop your own connector for whatever, you can do that with nothing more than the core license. So that's kind of the basics of the license model. Very, very simple. It's not capacity based. It's not MIPS based. It's not LPAR based. It's flat per operating system or per platform. Once you have it, doesn't matter if you're doing exabytes or just a handful of files. It's unlimited from a data consumption point of view as well. So very easy to do business with that way. Very easy to scale that way. There are and of course I'm just going to stress that as a relatively small software vendor, the advantage working with us is that we can be very flexible with most of these things too. So if you've got a unique case or third-party structure you want us to look at, we're happy to have those conversations too.
Great, you can go to the next. So PropelZ is one of our 4 products. I thought it would be good to have Vince sort of give a little overview of where PropelZ fits in this suite of products that we offer. Vince?
Yeah. So PropelZ that we've been talking about is replication. You've got mainframe data. It may or may not stay on your mainframe, but you're going to have another copy of that data somewhere. It's going to be replicated in whatever ways that you want. It's data centric, so it's transactional. You run it whenever you want, wherever you want, and it does its thing. FlowZ is a similar concept where, but really it's more application centric, and the idea is to help you exploit cloud data in your mainframe application. So I might have, for instance, backup software running on z/OS, but what I want to do is I want that software to just directly write backups in, let's say an S3 bucket or, some other target that's not mainframe data. So I'm exploiting cloud storage through FlowZ in virtually any mainframe application. So, it's not, in the sense that PropelZ is data centric, FlowZ is application centric. So it's enablement for mainframe applications to read and write storage anywhere in really any target that we support. The targets are similar to PropelZ. Honestly, what we see more frequently is targets that tend to be more file system oriented. So, object storage, NFS servers, SMB servers, those types of things. And the other thing about FlowZ is that it really makes it easy to do data sharing across platforms without any kind of intermediate transformation. So it's not, like PropelZ, you could do that too. You might say, I take my VSAM data, populate it into, let's say a SQL Server database, and then I run my application against it. With FlowZ, I would be creating probably more file structures that could be directly either read or written by applications on both sides, by mainframe applications as well as non-mainframe applications. So that's the FlowZ space. Lozen is to be clear, it's not replication. Lozen is the idea that you just want your data to remain on the mainframe, but you want to provide access to it anywhere you need it. So the way to think of Lozen is, imagine if you had an ability to access, let's say your VSAM data really anywhere, in any application. It could be in the cloud, could be on your mobile device, could be virtually anywhere. Lozen can provide that. And instead of replicated solutions, there's only one copy of the data, and it's the live running data on your z/OS system. So high integrity, it's high security. It leaves the data on the mainframe, but it allows you to access it from virtually anywhere. To certainly the very mainframe centric operations love that. There's no loss of control. Your data is still protected by your mainframe security policies, your mainframe management tools. All of that continues to be your source of truth for that data. It's just now I can have, let's say a Java application running in the AWS environment that can access that data. And not only that, but there's no loss of functionality. If I want to do sophisticated VSAM-ish stuff, open a file, position to a certain set of records based on their keys, read some, update some, delete some, read backwards. I mean, all the things you can do with VSAM, you can do through Lozen no matter where that application is. So it's very much like providing universal access to mainframe data in a shared model such that that data never has to leave the platform. And then, finally, Zaac is what I hinted at before. Zaac is a virtual disk and tape model for ZOS. So with Zaac, I could take either on-prem storage or cloud storage and make it look and act and behave all the world like it was local mainframe disk. So, instead of spending millions of dollars for a mainframe disk, I can do, exactly what I described before. I can go get a little bit of S3 storage or cloud storage, or, connect to my iSCSI LAN that might be 20 feet away from my mainframe. And I can use all of that storage just as though it were a local mainframe disk. So, that again, it's stuff that we've been doing as an industry on other platforms for, I don't know, 10 years now, at least, maybe 20 years. It's just the mainframe's never been able to participate in that. Zaac allows for that today. And especially when we look at things like on-prem models. I mean, I have a local SAN device here that's just a few $1,000s. It's scalable up to hundreds of terabytes, and it performs amazingly well for what it is. So we really think that however you're looking at this data sharing and how does a mainframe fit in, and what are the different options here, probably a little bit differently from our competitors. Our answer is tell us where you want your data and we'll make it happen. And we're not locked into any one model. We have a wide range of solutions that can cover just about any need here.
Yeah, that's great. Thank you, Vince. So just to, we've really not only tested this in our labs, but we have had this tested and run on multiple client locations. This is an example of Jerry Edgington from Polera talking about their proof of their running it in their environment and what they saw. Vince, do you have anything to add on this slide?
Yeah, no, I mean, the only thing I would add is that these are pretty typical results. I mean, especially that installation experience, like a lot of software vendors, we connect with prospects, we get to the point where they're ready to try it, and we assume there's going to be hand-holding work to do. And more often than not, we hear, oh yeah, I just took it and I'm up and running. And we don't even hear about that a lot of times. It's just, they're able to be, very self-sufficient that way. Jerry Edgerton here, perfect example of that. We sent them the software one day. Next time we checked in, he had everything up and running, everything configured, understood what he needed to do, and was getting results already. That's a very common pattern we hear all the time.
Great. Thanks, Vince. Jeannie, you can switch. So I guess just to close, I just wanted to make sure everyone understands that if any of these problems are something that you want to talk about more, the links are right there on your screen. Schedule a briefing with us. We're glad to show you this against your own data. And just in general, we are very open and with our with all of this information. Feel free to go to our website and look at all the videos and the content there. And is there anything that we haven't talked about, Vince, that you wanted to bring up just before we close?
Yeah, no, I mean, I would definitely encourage everybody to, take a look at our website. I mean, we have demos and videos and, other things just like this, where we've gone into some of these in, much more detail. And by all means, don't hesitate to, reach out to us. We're accustomed to having these discussions, and if you have something that feels like this, insurmountable problem, or you're going in circles trying to use whatever you're trying to use to solve it, I mean, we can probably help there.
Definitely. Well, thanks everyone for listening and watching, and good luck. Bye now.
Hi guys.